Welcome back to CJay's video notebook. This is part 3 of our DOL motor control basic series, and things are about to get even more exciting. In this episode, we're stepping into real-world industrial logic, where motors control other motors, timing relays bring precision, and jogging circuits give you total control down to the second. That if you've been following along, you're not just learning circuits. You're building the skill set of a true control systems technician. So grab your notebook, stay focused, and let's dive into the circuits that bring automation to life. This is a direct online, or DOL starter circuit, the simplest and most widely used method for starting induction motors. The three-phase power supply enters the system through a protective circuit breaker, then flows to the magnetic contactor. From the contactor, the line continues through the overload relay and finally reaches the electric motor. On the front of the contactor, you'll notice two wire terminals labeled A1 and A2. These are the coil terminals. When a control signal output voltage is applied across A1 and A2, the coil energizes, pulling in the contactor to close the main power circuit. In the upcoming slides, remember this key point. The signal we'll refer to as S1 output corresponds to the activation of this magnetic contactor. It's this S1 output that energizes the coil via terminals A1 and A2 as illustrated here. This control circuit is designed to automatically start a second motor whenever the first motor is energized. It's commonly used in systems like conveyors, where one part of the process depends on another. By using the auxiliary contacts of the first motor starter to trigger the second, this setup removes the risk of the operator forgetting to start the second motor. In this diagram, NEMA-type auxiliary contacts are shown, with terminal references provided on the top right. This control circuit automatically starts a second motor after a preset delay once the first motor is energized. Instead of using auxiliary contacts, it uses a time delay relay to create a gap between motor startups. This setup is especially helpful when dealing with large motors, where starting both at the same time could cause a power surge or overload the system. The timing relay ensures a smooth, sequential startup. Pin numbers and timing settings are shown in the diagram on the top right. This circuit adds flexibility by allowing motor control from two different locations using a local off-remote selector switch. In the local position, the motor can be started or stopped directly at the switch. In remote mode, a distant push-button station controls the motor instead. This setup is ideal when the motor is physically far from the control point, letting the operator manage the motor locally without needing to walk to the remote station. This circuit introduces the jog function, which allows the motor to run only while the jog push button is being pressed. Unlike normal operation where the holding contact keeps the motor running after it's started, the jog circuit prevents the coil from staying energized. This is ideal for positioning tasks, where the operator needs short, controlled bursts of motor movement. When the jog button is pressed, the motor runs. When released, it stops immediately. The design uses a two-circuit push button that temporarily disables the holding path while jog is active. That's a wrap for part 3 of our DOL motor control basic series. Today, you've seen how control circuits can go beyond the basics, starting motors with timing relays, jogging for precision, and linking motors together to work in sequence. But we're just getting started. In part 4, we'll dive into interlocking circuits, multi-motor coordination, and even fault-safe logic, the kind of circuits used every day in real industrial control systems. So if you're serious about mastering motor control, you won't want to miss what's next. Make sure to like, drop a comment with your thoughts or questions, and subscribe to CJay's video notebook so you never miss a new upload. Thanks for watching, and I'll see you in part 4.